We're going to talk about type checking, but let's first talk about types. What does a type mean in the context of a computer? So if we take a look at computer's memory, instead of strings or numbers or dictionaries, all we have is a sequence of zeros and ones. And the question is, how should a program interpret these sequences of zeros and ones? What a type does is two things. First, it tells a program you should be reading these sequences in chunks of, let's say, 32 bits. So that's the first thing. The second thing that it tells computer is, what does this number here, this sequence of bits, represent? Does it represent a floating point number, a character, a piece of music, or something else? If you move data from one variable to another, if the types of these variables do not match, you could potentially lose information. So for example, if your program expects a floating point number, but you provide it with an integer, there is no problem, since integers are a subset of floating point numbers. However, if the program expects an integer and you provide it with a floating point number, some information is likely lost. Typing, or assigning data types, refers to the set of rules that the language uses to ensure that the part of the program receiving the data knows how to correctly interpret that data. Some languages are statically typed, like C or C++, and other languages are dynamically typed, like Python. So what do these two terms mean? Static typing means that type checking is performed during compile time, whereas dynamic typing means that type checking is performed at runtime. Consider the following simple example. If we tell Python x is equal to 3, how does Python know that x should stand for an integer? There are three important concepts here: variable, object, and reference. So when you assign variables to objects in Python, the following three things happen. First, if we type x equals 3, the first thing Python will do is create the object, in this case, number 3. The second thing Python will do is it will create the variable name x, and the third thing is Python will insert a reference from the name of the variable to the actual object. Variable names and objects are stored in different parts of computer's memory. A key point to remember here is that variable names always link to objects, never to other variables. A variable is therefore a reference to the given object. In other words, a name, possibly one out of many names that are attached to that object. When assigning objects, it's useful to keep in mind the distinction between mutable and immutable objects. Remember, mutable objects like lists and dictionaries can be modified at any point of program execution. In contrast, immutable objects like numbers and strings cannot be altered after they've been created in the program. To illustrate dynamic typing, I've written down here 3 lines of code. X is equal to 3, Y is equal to X, and finally Y is equal to Y minus 1. Let's work through these 3 lines of code. When we're first asking Python to run the first line, x is equal to 3, remember the following steps take place. Python first creates the object 3, then it creates the variable name x, and finally it inserts a reference from the variable name to the object itself. When we go and look at the second line, y is equal to x, the object x, in this case number 3, already exists. The next step Python does is it creates a new variable name which is equal to y, and then it inserts a reference to the object that x, variable name x, is currently referencing. Remember, a variable cannot reference another variable. A variable can only reference an object. We then move on to the third line, which is y equals y minus 1. Python first looks at the object here, which is our number 3, but we know that numbers are immutable. Therefore, in order to do the subtraction, a new object has to be created, which in this case is the number 2. We already have the variable name y in our computer's memory. So the final thing Python does is it removes this reference and inserts a reference from y to the object 2. So once we've run all of these 3 lines of code, x will eventually be equal to 3 and y will be equal to 2. Let's then look at dynamic typing for mutable objects. The behavior for mutable objects, like lists and dictionaries, looks different, although it really follows the same logic as for immutable objects. To illustrate the concepts, I've written down 3 lines of code. Let's start from the first one. L1 is equal to a list, which consists of the numbers 2, 3, and 4. Let's think about what happens as this line is run. First, Python creates the object, list 2, 3, 4. The second step, Python creates the variable name L1. And third, because of the assignment, L1 will reference this list. If we look at the second step, L2 is equal to L1. The object L1, which currently references the list, already exists. Therefore, Python only needs to do 2 things. The first thing is it creates the variable name L2. Because L2 cannot reference L1, which is another variable, it must reference the object that L1 references. Therefore, L2 essentially becomes a synonym for the very same object. When we look at the third line, L1 at location 0 equals 24. In this case, what happens is we're using the name L1 to reference this object, and we're modifying the content of the number at location 0 from 2 to 24. After this modification, the content of the list is going to be 24, 3, and 4. By looking at the code here, your first impression might have been that you have 2 lists, L1 and L2, and only list L1 gets modified. However, if you understand how dynamic typing works in Python, you'll realize that we only have 2 names that reference the very same object. The last line, L1 at location 0 equals 24, would have been identical to typing L2 at location 0 equals 24. This is again for the reason that both of these variable names, L1 and L2, reference the very same object. Each object in Python has a type, value, and an identity. Mutable objects in Python can be identical in content and yet be actually different objects. Let's illustrate this point with a simple example. I'm going to define a list, L, which has the elements 1, 2, 3. And I'm also going to define another list, which I'm going to call M, and it also has the elements 1, 2, and 3. I can compare these lists using 2 equals signs. So I'm asking, is L equal to M? When we're comparing 2 lists, the actual comparison is carried out element-wise. So the 0th element in L is compared with the 0th element of M, and so forth. In this case, the content of these 2 lists is identical. Therefore, when I ask is L equal to M, Python returns true. But there is another way how we can compare these 2 objects. We can also ask, is L the same object as M? And in this case, Python returns false. What's happening here? We can use the ID function to obtain the identity of an object. And the number returned by Python corresponds to the object's location in memory. So if I type ID of L, Python returns a number. If I type ID of M, Python returns another number. You can think of these numbers as some type of social security numbers for these different objects. So typing L is M is really the same as typing is the identity of L equal to the identity of M. The main point here is that mutable objects can be identical in content, yet be different objects. Consider a situation where we have defined a list L, again consisting of the numbers 1, 2, and 3. What if I wanted to create a copy of that list? Remember, if I type M is equal to L, In that case, M is just another name for the same list, L. But what if I wanted to create a completely new object that has identical content to L? The easiest way to do this is the following. I can ask Python to create a new list and then assign that list object to a new variable. This is the syntax. I already have my list object L in the computer's memory. By typing list parentheses L, Python will create a completely new object for me, but the content of that list is going to be identical to the content of list L. In this case, if I ask M is L, I get a false. That's because these two objects are distinct. But if I ask, is M equal to L in content, the answer is going to be true. Another way to create a copy of a list is to use the slicing syntax. So I could have said something like M is equal to L, putting square brackets, and taking every single element from the list L. This results in the creation of a new list object, which is then assigned to the variable name M.